Hi guys, welcome to Learn Electronics Repair. I have another amplifier here. So this one, MF-1200 MOSFET professional power amplifier. The first thing I notice is that the switch is kind of like broken and a bit hard to show you. I'll show you a bit closer, but doesn't look good. Okay, so look. That doesn't look too promising. I think he said it was a fault on one of the channels. I think with this one, I'll actually open this up first. Let's have a quick look to see what's going on with this switch. And let's see if there's any obvious short circuits or anything like that. And then we'll try and power it up. This thing is incredibly heavy, by the way, I will mention that. Some of you might wonder, you're going to ask me maybe, why sometimes do I power these things up first and see what they do, and why sometimes do I say I have a look first inside. And I think it's kind of hard to explain in a way. It may just be down to my mood on a given day. I mean, in this case, because of the broken or damaged switch, and that's mains coming through there, I feel I should check it first. Sometimes, for whatever reason, I think, no, let's power it up with the current limiter first. So that's why I chose in this case. How do you work? What's your method? Do you have a different way? You know, how would you decide the initial position to start the repair from? Yeah, down there, tell me. So let's get the top off this and let's have a look to see what we have. So there we have it, guys. 2 transformers, 2 bridge rectifiers, 2 banks of large capacitors. It may be that one power supply is for one channel and the other one for the other. The other possibility is this is a class G amplifier, so one has a higher voltage than the other. I'm just looking where all these wires are going, so yeah, we have a red and blue here, a red and blue here. A little bit hard to say because they're all kind of like fastened down. Okay, but we could measure on the bridge rectifiers to see if they're both the same, I guess, or different. So then we have 2 large amplifier modules with heat sinks down there. Okay, and then this power switch, which is in the bottom. Let's see if I just zoom in onto that a bit for you guys. Okay, it's here. So you can see the contact is switching inside the switch. Yeah, it doesn't seem to, well, pushes in and out a little bit, so I do that, but yeah, okay. Yeah, maybe that switch is actually okay, although it wants replacing, to be honest. But may function, basically. Okay. This looks like some sort of voltage regulator board here. Okay, maybe plus or minus 15. Can't easily see. Oh, it also says speed on it. So this might be a fan. Oh yeah, I bet it's a fan controller. It says speed on the board. You might just be able to read that, and then yeah, it looks like that goes to the fan. Okay, maybe. This looks like power rails to me. Okay. And then we have another connector there with another bunch of them. And the same on the other channel, but it's physically mounted the other way up. So the connector for that one is down in there in the bottom. Okay, we see that. And the same as this one is kind of buried down there. I'm sure I've seen an amplifier basically like this before, to be quite honest. Let's have a look to see if there's any sort of schematic available for this, or service manual. So the amplifier is this one, Altair MF-1200 schematic. And look, so I have looked at one of these before. I thought you looked very familiar. I don't know if it's the same one. This was, it says a year ago, but that could be up to 2 years ago, of course. So this one had a thermal error on one channel. Well, maybe I can learn something from myself and see what I did with this one. Okay, so what I can say from the first video, it's not the same amplifier. because we can see here this has different brand capacitors. Okay, I also made some markings on these which are not on this one, just to say which was which channel and where they were from. So it's not the same one physically, it's just another one of the same model. Okay, I actually repaired this one, so it had thermal error on one channel. I didn't look right through to see what exactly was causing the fault, but I did repair it. But I do know where the power comes in on the amplifier board, so I know where to look for shorts. So basically this cable, this goes to the front panel display on this where the LEDs are. Okay, I worked that out myself last time. And this one is power and speaker out. These are basically for the thermostats on here, by the way. That's what that board actually does. So let's look at some shorts around these connectors. And I see resistance climbing up. Resistance climbing up. I can't easily get to the other one though. By the way, it's at the bottom of that one. So what I can do is measure across the bridge rectifiers, which is the same basically as measuring across the capacitors. So there's no short here. Let me just check, make sure I have a good connection. But yeah, I just have a resistance climbing up, so there's no short there. Here to here, same sort of thing, resistance climbing up. You can also test to ground, I think is that black lead. Yeah, resistance climbing. Going the other way, charging the capacitor. Same thing. That reads a bit different, but it's not a short at least. We do have this relay in this circuit somewhere, but what I've just spotted down here is a power resistor, a large one, which says it's 10 ohms. I can read it. I wouldn't be surprised if this relay shorts that resistor out, so that resistor just stops too much inrush current when we first connect the mains, and then this shorts that resistor out. That's a very standard sort of configuration. Often we have a thermistor instead of a resistor, but it's the same thing, okay, to all intents and purposes. So let's try power this one up and let's see what we actually have. So we can see the front panel, we can see the LEDs, we can also see the light bulbs just over there actually. So we can see what we need to see. I'm not sure which way the switch actually goes. I don't really want to mess with that particularly. Okay, so I'll just try it in this direction, hit the power. They come on, then they go dimmer. Okay, so it's not going to go bang. It's drawing quite a bit of current though. I mean, that's 150 watts. Let's go again. Okay. Oh, relay went quick, so it charged the capacitor, something went quick. So it's not going to blow up, that's fair enough. So we'll switch this directly to mains and we'll go again. So no lights on the front, light up, just the power. And we hear a relay, okay? Nothing else. So nothing happening, clip, signal, error or thermal. That's like there's kind of nothing wrong with it as such. Let's see if we still have a charge in these capacitors. And I can measure this across here. Okay, so 8 volts going downwards. Minus 18. Also going downwards. Okay, so this one went down a bit faster than the other one. 5, 4. Minus 15. So I can't easily get to that one. So there's no shorts, nothing. I think then what we need to do now is attach a signal and see if this actually gives audio on one or both channels. Well, let's see. Power on. Click. Another little click. Okay. Give it some audio. Turn it up. Well, one speaker's working for certain. Yeah, I have one channel working. Okay, I was just checking which channel actually works. So the one with the white connector is working, and the one with the red, that's the red one. You can't easily see the white one. You can now. So that one's working and this one isn't, okay? So I figured this out on the previous repair of one of these. These yellow wires are the speaker output. Okay, the other end of the speaker is ground. So one of these speakers will connect to this amplifier. That one, and then the other one doesn't, okay? That goes to that one, which is kind of like the connector's buried down there. So this one is the channel that's working. This is the channel that isn't working. That one. Okay, top. That's just so I know which way round it goes. So based on what I did with the previous one, I actually swapped the two amplifier modules over to see whether the problem was on the amplifier or somewhere in the support circuitry, and it worked last time. So I think that's the way we should go with this. These were not too difficult to take apart, so we take these bolts out, and then there's only a few connectors we can take the boards off. So let's do that. We can have a comparison between the two. Remember, this is the one I can't say for certain if there's a problem with that, if there's a fuse gone or there's no power getting to it, but once we take these off we should be able to do that quite easily. So let's do it. I commented last time on these being fairly easy to work on. So that's some sort of temperature sensor. It says sensor. That was one of the pink wires. Okay, we have this one which is going to here, which goes to the front panel with the LEDs on. This is your power and speakers. Okay, this one must be the signal input. It goes down to the volume control somewhere. So that's that one. And then there's a blue one here, which actually you don't need to unplug because it just goes to the heatsink. And then we have here balance in, something like that. Balanced in, okay. And in, yeah. So there's inputs on the back, both XLR, which is balanced, and there are jack inputs as well. There's also a switch down here, stereo mono, so mono is bridged mode. It is set to stereo, so both channels should work. And there we can see all the output devices, okay. So that's that one off. And then we can do the same with the other one. So just undo these two bolts, basically. And this should lift out. We have to just get that thing out first. We'll get the bolt out first. There we go. Okay. So with this one, we have the same sort of thing. I'll put some little marks on this actually. So that goes to there. This one we can make it like a wider mark. Okay, so that goes to there. Okay. I'll take the bolts out. And again, we should be able to lift this up. We have a connection down here, that one. Just put a line then. I know the line lines up with the line, basically, that goes there. This one you don't need to disconnect, and this is the orange one. One more, and that's the power. Right, so this one's off also. So here are the two amplifiers. This is the one that doesn't work, okay, this one. Just put a mark on here as well so we know which one it is. Now the first thing I notice is this resistor appears to be big, but this is the good one. This one works. Let's have a look. So we'll go to ohms range. Well, that reads open. Also reads open. So you can see this one's Discord. That underneath just says 25. I don't think that's a value because this one, for example, says 37, and that's clearly a 2.2K. Red. Okay, so that reads open, but this one works. We'll put this meter, it's easier for you guys to see. Okay, so yeah, it's pretty much zero. Same. Yeah, so they're all connected together. In fact, we can see that the track runs along that. So that's all the source of the MOSFETs, which we know are N-type and P-type mixed, or rather complementary, 4 of each. This one, that reads about 11 ohms. That's strange because I mean they bolted to each other. 11. Well, that reads 0. This is like there's not a very good connection on some of these MOSFETs, I think. Well, I don't see how I can have a resistance from here to here when they bolted onto the same track, unless I have some sort of corrosion. So that reads 2 ohms on that one. That reads okay. So these are obviously, for some reason this one's not inserted all the way. Oh, that goes behind there, so they can't insert it all the way. That's interesting. Okay, bad design. Well, as long as one's bolted on, that should be fine. So let's just try and tighten the bolts on this one. Okay, that's tightened. That's already pretty tight. Okay, so I've tightened those two down. Let's try again. In fact, actually now I can see that this one here isn't really bolted in correctly either. Well, this is not going to help. I'll just go along all of them. Make sure they fasten properly. They're not really tightened in properly. Yeah. Now it is. This might be something to do with why it doesn't work. That one's sheared off. Well, that wasn't very good. I'm sure I can find another bolt for that though. This one is just kind of like turning around, nothing there really. Okay, nothing to bolt into. This one, okay, yeah, they're tight now. I won't worry about the sheared one at the moment because obviously this one will be bolted down anyway. Okay, let's measure it again. So this one, 0 to this one now. Yeah, basically 0, so that one's connected now. Okay. Yeah, that one is just needs another bolt in here. That one is. This is looking better. That reads the resistance, but we knew about that one. Okay. And actually we see the same on this, so it's fitted the other way and there's no nut on that one. Okay, so that's looking better now. This one is really rusted at the end here, but yeah. Okay. 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 That one has a resistance. That one's okay. So this one, where there's only one bolt, yeah, it is about half an ohm. Let's see if we just tighten that a little bit. Okay, try again. That reads okay. So that's the first problem. So we've got two things going on, guys. This one appears to have a faulty resistor, but it works. And that one also appears to have the same faulty resistor, but it doesn't work. So I'd say that's not what's stopping it from working, at least. How's this connected? So we can see we have plus supply, ground minus. That's some sort of sense, I think. So minus supply goes to, yeah, all the drains of these ones. And then the plus supply goes to the drains of these ones, I think. Yeah. Okay. Yeah. And then all of these are connected together from both pairs. So this must be like the speaker connection. So here's a speaker, but it doesn't go to there. Oh, but there's a relay. So that goes here. Yeah, and that must go to the relay and then to the connector. Okay, so all the connections make sense. Now let's just check for any shorts. So we know this is ground from the negative. Kilo ohms and climbing. Positive. Kilo ohms and climbing. Same on this one. 6k, 5k, yeah, similar. And from the ground to the negative, again climbing up, okay. And then from the junction of all these to the positive, kilo ohms, negative, kilo ohms, and on this one, kilo ohms and kilo ohms. Okay, so apart from these faulty resistors and these loose bolts which wouldn't have helped, I don't see anything other obvious different with these. No shorts. Let's have a look. So if we look from the resistor, yeah, so this is this effectively speaker out via the relay, and that goes to one end of this resistor. That goes into this little network of components. I think this is some sort of like filter. It comes back to the thing via these two caps to here. I think there's some sort of filtering thing for high frequencies, maybe. So having this resistor not working is going to stop that from working, but looks like it doesn't stop the amplifier from working. Okay, so let's put this one back into the front position and let's see if it works on that side of the amplifier or not. Oh, just before we do that, let's have a look at the gate. So gate to drain, this is the working one. Ammeter's working, that reads open, and to the source reads open. Yeah, basically. On the other side of the amplifier, open, open, and then on this one, so gate to drain, that's going to go open basically. Yeah, it's in the mega ohms already. Oh, there's a bit of a difference there. Actually, we might have some difference here, on this amplifier, gate to drain, and on the other side, gate to drain. Yeah, some sort of resistance. Gate to source, some resistance, gate to source, some resistance. So there is a difference between the two if you look from the gate. Yeah, definitely. Well, the gate of the MOSFET to the drain and source should effectively be open. It will do out of circuit, so that suggests that there's something different in the drive, which is these two. So let's just check these as well. I think these are the drive into those two, into the gates, just a guess. So this is a bipolar transistor. Okay, diode mode. What do we have? Base collector 2.9, 2.7. Let's go the other way around. So negative to the base, PNP. Reads like a diode. Reads like a diode. This is the good channel, of course. So I'm expecting this to be the complementary. Reads like a diode. Reads like a diode. Then on the bad channel, reads like a diode. Reads like a diode. Reads like a diode. Reads like a diode. Collector emitter, this is the PNP, so negative to the collector, 0.698. This one, not far off. And the other one, 1.4. Yeah, not far off. Okay, so we have some bit of a strange thing around the gate on those, but that's the only thing I can see. Now we will put this one in on the other side of the amplifier and see if the fault is on here or something that feeds into it. Oh, this worked out quite handy actually. So I can actually rest the amplifier module here. I've got it on these pieces of card because the bolts that run through this are all insulated from the heatsink. Okay, it's insulated from the metalwork. So I've rested on this cardboard, nothing's touching anything. We can power this up again with a current limiter just to be sure we're happy with the way it's gonna work. And then again, we can put some audio and see if this channel actually works when it's connected on this side of the amplifier. So first of all, power on. Light bulbs are going dim, I'm happy with that. So we go straight to mains, power it up. Okay. And then what happens with some audio? So we'll just give it a little bit. Okay, and this channel doesn't work here, okay? There's no error lights on, it just doesn't work, but it makes it easy to test, which means we can easily put the other one here, just to confirm that is working like this, and then we can actually probe around this one if it's faulty and see what the problem is. And this is the working channel. So I've just connected it up as I connected the other one. I just want to make sure it does work like this. And then hopefully that's the case, and then we can start to make some comparisons between the two. So just the light bulb on just to be certain. Bright and then going dim. You're happy with that, okay. Switch it on, power up. Relays go quick. Let's put a bit of music on. Okay. Yeah. So we have a working one there, which we knew, and it is working like that. So I think we have a couple of options here. We can either trace the signal through on this one and then compare it with the other one, or we could have a look to see if we can spot any difference between the two with the multimeter first. Let's just see if I can actually find, I did look before, but if I can find the schematic for this board, that would help in tracing it through. Otherwise, I would probably be trying to figure out how the signal gets to the gate of the output device is where does it come from. So I'd have to track that through and then probe there. One thing I can just check though, I will check on the other one, is just to make sure that we do have supply voltages on it. So with this one as it stands, we know that the area here, this is one of the supply rails, this is the other supply rail, and we know ground is on the black lead. So let's just try. The only reason I could think we wouldn't have a supply on the other one is if there's some open circuit resistor or something somewhere. I mean, I don't see any fuses. Okay, so we'll power this back up again. Let's have a quick look. So on the drain here should be, yeah, 90 volts, and on this one, yeah, 90 negative. So it's a plus and minus 90 supply. See, it's just discharging quite happily on its own there. Okay. While that's discharging, let's have a quick look at this. I just want to trace through so I can figure out where the drive comes into the MOSFETs, where it's coming from. Then we can look on this one with a scope, and we can look on this one and just check the voltages, and that might give us some idea. I've had a quick look, guys. So we have the gates of all these MOSFETs. You can see go to these resistors. So from here to here, connection, and then this is a 1K resistor. There's another one here for this one. So each MOSFET has its own 1K resistor. Okay, another one, and then those resistors, the other ends all connect together. Okay, and that actually goes here to this track, and it goes to the collector of this transistor. So that's driving the gate of these ones. Then on the other side, basically the same. So we have the gates going to the 1K resistors. There's one of them here. Okay, another gate, another resistor. So each one has its own resistor, and all the resistors again, the other ends connect together to each other. Like these are connected to each other, and they're connected over here as well. And those go to the collector of this transistor. Okay, so these are driving all the output stages, and that's probably a good place to look for a signal, I would think. So what we do with the good one, because it's still connected to the amplifier, let's have a look there, let's have a look there, see what we have, and we'll compare it with this one. Okay guys, so this is the working channel. I've connected a tone generator now, but that's going to drive you crazy. Yeah, so I think I'll actually just disconnect the speaker, and we can still monitor on the scope what's happening with this amplifier. So I'll show you the scope as well. Okay, so the speaker is disconnected. Just switch it on again. Okay, I'll give it a little bit of drive from the mixer. It's not making that noise we can hear. Horrible, yeah. And what do we actually have? So this is what is going into the amplifier on the gate. Okay, we can see it. So I have it set to 5 volts per division. Okay, 1 kilohertz, saying 6.7 volts, 7.5 volts. So that's what we actually have there. Okay, and here is the bad channel. So I've attached the scope to the same place on this one. Let's see what this does. What waveform do we have? So switch it on. Okay, so we have the same sort of drive there, going as far as the output stage. Yeah, same sort of voltages. So that tells us there's drive to the output MOSFETs, or there should be. We can check all the gate resistors. The other thing is, let's just check the voltages to make sure we do have the voltages here. So I've turned the input signal off for the moment, because this is how we measured the other one. So drain voltage 90, -90, so that's okay. There's a relay closing. This is a good question. First of all, do we actually have any output from the amplifier? And secondly, is that protection relay closing? I mean, we have no error lights on the front of it, but we better just check to see if anything's actually coming out of this. This is easy to do, so we can just clip the scope onto there. So we're just on the yellow trace. Let me put it back on the screen again. Okay. There you go. So the cyan one isn't doing anything now, just the yellow one. I'll move it up towards the middle because the voltage is likely to be higher here. Take channel 2 off. Okay, what's coming out of the amplifier before the relay? Okay. Well, let's see. So on. Nothing. Interesting. That suggests we have a problem with all the output MOSFETs. I mean, well, we can check that easy enough. If we go onto one of the gate resistors, so this is the end that's actually connecting to the gate. Okay. Let's have a look to see what we get there when we switch on and give it a bit of drive. Okay. What do we have? Well, I don't see anything. I see nothing there. Just turn the sensitivity up a bit. Okay. Nope, nothing. Interesting. And on the other side, oh, okay. Just yeah, what I did there, just actually, it switched off, the capacitors are discharging, and it just shorted to ground with my clip there. But you say it switched off, so that's not going to cause any problems. Switch it back on again. Nothing. Well, that would suggest there's some problem with the MOSFETs on the bad amplifier, which is this one. Okay. We have signal going into the resistors on the gate drive, but nothing on the other side. Let's just check the resistors. I suspect they're okay. Let's see. So, yeah, 1K, 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 1K. On the other side. Yeah, 1K. 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 Now if we go gate to source, see that reads 870 ohms. That reads different. Okay, so there's something different here. Look, the first one, 2.8K, 870 ohms, 2.8K, 2.8, 3, 3, 3, 3. Compare it with the other one. So open. Aha. So that's what's dragging the signal down. That is open. They should, I mean, the gate basically should read open on all of them. Yeah. That tells me there's a problem with these MOSFETs on this one. I can't think of any other reason I would see that. So, in fact, we can even prove that more. So, for example, on this one, from gate to source, reads 870 ohms. And if we read from the other side of the resistor, do you read 1.8? Yeah, 1.8. So the low resistance is on the MOSFET side. I'm going to have to take the MOSFETs off this one, and then let's have a look at them. Okay, so these are actually coming out quite easily. These are like kind of like eyelets or kind of like hollow rivets. I'm sure there's a name for those things. Ringlets? Yeah, maybe. So once you get the bolts out, these are coming out just nicely. Okay, so I have a lot of MOSFETs. I seem to recall from these early MOSFETs not to touch the gate. Don't touch the gate pin. They were extremely sensitive to ESD, electric static discharge. So I won't do that. But what we will do is see if they're any good. Okay, so this one, it says it's good. Okay. So I've got all the J MOSFETs here. These are the P-type. Let's see. Look at that gate threshold, 0.21 volts. That's extremely low. They seem okay. Last one. That's bad. So we have one bad one there. That's also bad. That's okay. Yeah. I wonder why these old MOSFETs have such a low gate threshold voltage compared to modern ones. Because that would suggest they're better with a lower gate threshold. So I wonder why that actually is. I'm guessing one of you guys already knows that. Let's get rid of the camera. Don't need while we do this. Okay. Yeah, that's okay as well. So we have 3 good ones of each and 1 bad one of each. Okay. Just put these in here. So back in the 70s, when you got these like for your electronic projects, they actually came with tin foil wrapped around them to short the gate to the source. And occasionally I remember seeing them with paper clips across the gate and source. So we have 2 bad MOSFETs here, one J56 and one K176. The question, or is that J55? Let's be sure. Yeah, J56 and K176, okay. The question is, can we get these things? J56 MOSFET, I think it was actually a 2SJ. Let's see. Nothing like that. Let's try 2SJ56 MOSFET. Nope, nothing like that. And the other one is K176. Nothing like that. 2S. Nope. K176 and MOSFET, and then TO3. That's the package. Nope. Let's just search that outside of AliExpress, straight into the Google. What do we have? Wow! But somebody had them there on AliExpress, but he says the page cannot be found. Look at that. A picture, and then the page can't be found. What else? AliExpress. Can't be found. eBay? Yeah, $40. One pair, which I guess would fix this if I don't have to worry too much about matching to other ones, but they are in the US. Well, somebody on DIY Audio, somebody said they had a lot of them, but that was in 2019. Okay, guys, I know some of you are audio experts, so to repair this amplifier, A, is it reasonable just to get one pair of these and fit those alongside the old ones? B, is there some substitute I should be using? Or C, do you know where I can get a set of these without paying silly money for them? Okay, guys, well, I found the faults, and I'm pretty sure you'll be agreeing with me. I diagnosed it. The amplifier should work. We have drive going to the gate resistors. Obviously, one on either side was providing a low enough load just to pull them all down. That's the best way I can say. You guys, yeah, discuss with us down there. Hope you enjoyed that. I would love to repair this, so let's see what you say, and I look forward to seeing you all soon again on Learn Electronics Repair. Ciao for now.